Every planet we have ever observed exists in relation to a star. This is not a coincidence of observation. It reflects a fundamental assumption embedded in planetary science since its beginning, that planets form around stars, orbit stars, and derive their energy from stars. The solar system we inhabit is the template, a central star orbited by planets at varying distances, held in stable configurations by the same gravitational equilibrium that formed them. This assumption is wrong, or rather, it is incomplete in a way that took decades to confront directly. Planets do not always stay where they form. Gravitational interactions within young planetary systems are chaotic. Multiple large bodies competing for orbital stability frequently results in close encounters that accelerate one body and decelerate another. The decelerated body falls inward. The accelerated body is flung outward. If the acceleration is sufficient, the ejected planet escapes the gravitational influence of its star entirely. It continues moving outward into interstellar space at whatever velocity the ejection imparted, with no star to orbit, with no gravitational anchor, with no source of light or significant external heat. It drifts. This is not a theoretical possibility. It is a measured phenomenon, and the number of objects currently drifting through interstellar space in this condition is larger than most estimates of stellar populations in the galaxy. The first confirmed detections of free-floating planetary mass objects came from wide-field infrared surveys in the early 2000s. Objects too small to be stars, below the hydrogen burning limit of approximately 80 Jupiter masses, too large to be comfortably classified as anything else, detected in star-forming regions and young stellar clusters with no associated stellar host. The initial reaction in the astronomical community was definitional. Were these planets? They had planetary masses, but planets, by the then current understanding, orbited stars. Objects that did not orbit stars were something else. Sub-brown dwarfs, isolated planetary mass objects, free-floating planets. The nomenclature was debated for years. The International Astronomical Union's 2006 definition of a planet, the definition that famously reclassified Pluto, did not resolve the question of free-floating objects. A planet, under that definition, must orbit the Sun. Objects in other solar systems were not formally addressed. Objects orbiting nothing were not addressed at all. The naming problem was resolved practically, if not formally. Astronomers began calling them rogue planets. The name stuck, the way dark matter stuck, the way the Big Bang stuck. A label that communicates the essential strangeness of the thing without fully explaining it. By any working definition, a rogue planet is a planetary mass object moving through space with no stellar host. It formed, either around a star and was ejected, or directly from the collapse of a gas cloud too small to ignite fusion. And it now moves through interstellar space on a trajectory determined entirely by whatever gravitational interactions it has experienced since formation. Let's establish the count, because the count is where the scale of this becomes clear. In 2021, a study published in Monthly Notices of the Royal Astronomical Society analyzed data from the OGLE Gravitational Microlensing Survey, a program that detects the brief brightening of background stars when a massive object passes between the star and Earth, bending its light. Microlensing is currently the most sensitive method for detecting free-floating objects, because it does not require the object to emit or reflect light. It only requires mass. The analysis detected an excess of short-duration microlensing events lasting less than 2 days, consistent with Earth mass free-floating objects. The statistical analysis suggested a population of approximately 2 free-floating Earth mass objects per main sequence star in the galaxy. 2 per star. The Milky Way contains between 100 and 400 billion stars. At 2 rogue planets per star, the lower bound on the rogue planet population of the Milky Way is approximately 200 billion objects. 200 billion rogue planets. In our galaxy alone, a 2023 study using data from the James Webb Space Telescope identified 540 candidate free-floating planetary mass objects in the Orion Nebula, a nearby star-forming region, including 40 pairs of rogue planets orbiting each other. Planets with no star, orbiting each other. Binary rogue planets, drifting through the nebula in mutual gravitational embrace with no central star to provide light or energy to either of them. The existence of binary rogue planets was not predicted by the ejection model. Objects ejected from stellar systems do not typically leave in pairs. Their detection suggests that a significant fraction of rogue planets did not form around stars at all. They formed directly from collapsing gas clouds, the same process that forms stars, but in clouds too small and too diffuse to ignite fusion. Planets that never had a sun, not ejected from a system, born into darkness. Now let's talk about what the surface conditions of a rogue planet look like. The answer depends on the planet's mass, composition, internal heat, and age. A rogue planet with no star receives no significant external radiation. The cosmic microwave background, the afterglow of the Big Bang, provides a temperature of approximately 2.7 Kelvin above absolute zero. This is the baseline temperature of intergalactic space. A rogue planet in deep interstellar space, far from any star, will eventually equilibrate toward this temperature over geological timescales. 2.7 Kelvin is approximately negative 270 degrees Celsius, approximately 3 degrees above the coldest temperature physically possible. The surface of such a world, if it has a surface in any meaningful sense, would be a frozen landscape of solidified gases, nitrogen ice, oxygen ice, carbon dioxide ice, methane ice, every volatile compound that would exist as gas or liquid in the presence of stellar energy would be frozen solid on a rogue planet at equilibrium temperature. The atmosphere, if one existed at formation, would have frozen and precipitated onto the surface over millions of years. The oceans, if any existed, would be ice kilometers deep. There would be no wind, no weather, no cycle of any kind driven by external energy input. There would be no light, not the dimness of a cloudy day or the darkness of a moonless night, the complete absence of any photon source visible from the surface. The stars of the galaxy would be visible, faint points of light too distant to provide meaningful illumination, but the ground itself would be invisible. A surface temperature of 2.7 Kelvin does not emit infrared radiation detectable by any biological visual system. The rogue planet's own surface would be dark. This is the permanent condition, not seasonal, not cyclical, not subject to change by any external input. Permanent darkness, permanent cold, permanent silence. There is an exception to this picture, and it is the exception that has produced the most unexpected scientific discussion around rogue planets. Large rocky planets, super-Earths, objects 2 to 10 times Earth's mass, retain significant internal heat from their formation and from the decay of radioactive elements in their interiors. This heat, called radiogenic heating, continues for billions of years after formation, regardless of the planet's relationship to a star. Earth's interior is still warm from its formation 4.6 billion years ago. A significant fraction of that warmth is radiogenic, produced by the decay of uranium, thorium, and potassium-40 in the mantle and core. This heat drives plate tectonics, volcanic activity, and the convection currents in the outer core that generate Earth's magnetic field. A rogue super-Earth retains this internal heat source. Its surface is frozen, but beneath the surface, conditions may be different. If such a planet formed with sufficient water content, and water-rich planets are common in the current planetary formation models, and if the internal heat is sufficient to maintain liquid water at depth beneath an insulating ice shell, then the planet may harbor a subsurface ocean. Not a surface ocean warmed by a star, a deep subsurface ocean, kilometers beneath a frozen surface, maintained entirely by internal radiogenic heating, existing in permanent darkness and permanent isolation from any external energy source. This is not speculative in principle. We have an example in our own solar system. Europa, a moon of Jupiter, maintains a subsurface liquid water ocean beneath approximately 15 to 25 kilometers of ice. Its heat source is not radiogenic, but tidal, the flexing of Europa's interior by Jupiter's gravity. But the principle is the same. Liquid water in permanent darkness, far from any direct stellar energy input. Life exists in Earth's deep ocean hydrothermal vent systems without any connection to photosynthesis or surface sunlight. The energy source is entirely chemical, heat and mineral gradients from the ocean floor. These ecosystems were discovered in 1977 and fundamentally altered the definition of the habitable zone. If life can exist in Europa's ocean, if it can exist in the dark, pressurized, chemically driven environment of a subsurface ocean on a body that never receives direct stellar radiation, then the question of life on rogue planets is not immediately dismissible. A 2020 paper in the International Journal of Astrobiology modeled the habitability of subsurface oceans on rogue super-Earths. The authors concluded that such oceans could remain liquid for up to 5 billion years after ejection from a stellar system, depending on the planet's mass and radioactive element content. 5 billion years. The age of our solar system. An ocean in permanent darkness on a planet with no sun, maintained by the slow decay of radioactive elements, persisting for the entire span of time that has elapsed since Earth formed. The authors were careful to note that liquid water is a necessary but not sufficient condition for life. They did not claim that life exists on rogue planets. They established that the physical conditions required for the chemistry of life as we know it can persist on worlds that have never seen a star. Let's talk about what it means that there are 200 billion of these objects in the Milky Way. Our galaxy is approximately 100,000 light-years in diameter. 200 billion objects distributed across that volume produces an average spacing of, and this requires careful calculation because the distribution is not uniform, approximately 100 billion kilometers between rogue planets in the galactic plane. That is large. But it is not as large as the average spacing between stars, which is approximately 4 to 5 light-years. 40 to 50 trillion kilometers. Rogue planets are, statistically, significantly more common than stars. If you were traveling through the galaxy on a random trajectory, you would encounter rogue planets far more frequently than stellar systems. A 2012 paper in Nature by Strigari et al. Noted that the galaxy may contain more free-floating planets than stars, and that some fraction of these may be ejected with enough hydrogen envelope to remain geologically active for billions of years. The nearest rogue planet to Earth has not been identified. It has not been identified because rogue planets are extremely difficult to detect outside of the microlensing technique, which requires a specific geometric alignment. Direct imaging of rogue planets requires infrared sensitivity sufficient to detect objects producing very little thermal emission, at distances that could range from light months to light years. The nearest rogue planet could be closer to Earth than the nearest star, Proxima Centauri, at 4.24 light years. We would not know. It would be invisible to all current surveys unless it happened to transit a background star in a microlensing geometry. There may be a world, planetary mass, possibly with a subsurface ocean, possibly with conditions that chemistry would find interesting, drifting through the space between our solar system and the nearest star, moving slowly, going nowhere in particular. We would not see it. It produces no light. It reflects no light. It is dark against a dark background. The assumption was that planets orbit stars. The assumption was reasonable. Every planet we had ever observed was in a stellar system. The physics of planet formation centered on protoplanetary disks around young stars. The habitable zone was defined relative to stellar luminosity. The search for life was organized around the search for Earth-like planets in stellar habitable zones. The assumption produced 200 billion counterexamples in a single galaxy. Planets born into darkness. Planets ejected from the warmth of stellar systems into permanent cold. Planets drifting through interstellar space on trajectories that do not intersect any star, toward destinations that do not exist, for timescales that exceed the current age of the universe if followed to their gravitational conclusion. Binary rogue planets orbiting each other with no star between them. Substellar gas clouds that collapsed directly into planetary mass objects without ever producing fusion. Super-Earths with subsurface oceans maintained by radioactive decay, in darkness so complete that no photon from any star has touched their surface in billions of years. The universe does not organize itself around our definitions. The category of planet was constructed to describe objects in our solar system. The universe produced a population of planetary mass objects that does not fit that category and exceeds the stellar population of the galaxy. The darkness between the stars is not empty. It is full of worlds that have no sun. We have not looked at them. We have barely confirmed that they exist. We do not know how many have liquid water. We do not know how many have chemistry. We do not know whether any of them have anything more than chemistry. We know that 2.7 Kelvin is the equilibrium temperature of intergalactic space. We know that radiogenic heating can maintain subsurface liquid water for 5 billion years. We know that life on Earth does not require sunlight to persist. Everything beyond that is darkness. This is the 10th video in this series. We have covered vacuum, neutron stars, the Great Filter, gamma ray bursts, dark matter, the heat death of the universe, untracked asteroids, tidal disruption events, and now the dark worlds drifting between the stars. In each case, the conclusion has been the same. The universe is larger, stranger, and less organized around human categories than our working assumptions suggest. The gaps in our knowledge are not small refinements at the edges of an otherwise complete picture. They are structural, fundamental, present in the 95% of the universe the standard model does not describe. In the billion dark neutron stars we cannot track. In the 200 billion rogue planets we have not observed. In the filter that stopped every civilization before us from becoming detectable. One question. If a rogue super-Earth with a subsurface ocean passed through our solar system at a distance of, say, 1,000 astronomical units, close enough to detect with current or near-future infrared telescopes, far enough to pose no gravitational threat, and we confirm the existence of liquid water beneath its surface, what would we do with that information? Not the policy question, the personal one. What would it change about how you think about the dark between the stars? Drop your answer in the comments. See you in the next series.